Hello and welcome back. And let me turn off this fan. I don't know if it shows up in the recording or not. But anyway, hello and welcome back. And this is our series on creating a programming language, a custom programming language completely from scratch in C++ using tools such as Bison and Flex and doing unit testing. And we're doing it all. And yeah, so what we did last time is we created our singleton class for an object pool. That was good. Oh, wait. Yeah, I'll go ahead and say what we're doing. I'm sorry. I just was like, do I need to say this yet or not? This isn't polished. I'm not a professional, okay? But last time, that's what we did. We created our singleton object pool class. And it works for, some sort of class. Okay. For some sort of object. Now we need to create our what's the best way to put this? It's almost like our own. It's a garbage collected value that we can pass around. And there's a couple of reasons we're going to do this. First of all, it's to replace the idea of using. And I'm sorry, I'm going to have to turn on the fan because it is hot up here. I'm upstairs in my house and it's a little warm outside. But anyway, yeah. So we're creating a garbage collected container that can hold our values, and the idea is that we should be able to I'm trying to figure out the best way of saying it. Um, that we should be able to create a value, and ultimately we want it to pull from our object pool, and it keep track of how many copies of itself exist. And then when the last copy of it goes away, that it frees itself or recycles itself back into our object pool. That's what we want. If we were to use shared pointers, which is the modern C++ way, the problem is the shared pointers are slow, especially when passing them through functions. I did tests with this, and it's not slow. We're good there. Well, I mean, it's faster than shared pointers all over the place. But plus, it would use our memory pool, and shared pointers I don't think can use the memory pool. They can use a memory pool approach, at least not that I know of. And so we're just having to build these several things. Now, before we get started, I need to address one last thing, and that is the end of we added unit testing at the end of the last video, and evidently I did not add into the instructions that if you go to the website, and by website I mean GitHub and the GitHub, the Tang, right? If you go there and you go down to the installation instructions, it doesn't say anything about Google Test, and it should. So, simple enough. I have git diff. I added Google Test to the list of things that should be installed. To build instructions. Yeah. Okay. I should say git add readme, and now git commit. Okay, that's fine. We can go on from here now. So we're trying to create a garbage collected object, and we're going to be using templates. So I want to be able to say, give me a garbage collected whatever. And in fact, I think I'm going to go back and forth on this, but I think I'm going to start off with the test of actually the make file. Why? Because I want to add a test file for this thing that we're about to build. And so we have this test singleton object. Oh, that's what I was going to do as well. I was going to the singleton object. So what is this? Where is this? Dot slash build slash apps slash test. We run, not test. We want test singleton object pool. And you see how it runs all the tests. And if we do it, I think if I add a dash dash help, because, yeah, so we can say different things, but that's what I want. gtest brief is equal to 1. And so I bet if I do gtest brief is equal to, oh wait, equal to 1. Yeah, it'll only tell us that. So we're going to add that to the make file first. So when we're not compiling, but when we're running the tests, when we do make test, where is this? Oh, that's for compiling, making the test. Where is test? Oh, here we go. gtest underscore brief is equal to 1. There we go, and we will add this here. gtest brief is equal to 1. And now we're going to copy these, and we're going to add our, what are we going to call this? We're going to say garbage collected. Okay, why am I doing this? Because I want my code to read in a certain way. I want to call this garbage collected, you know, and whatever type goes in the parentheses, computed expression integer. Okay, so it's going to be called garbage collected. So down here, test garbage collected. And now, if we go up to where we compile them, our unit test, there we go. And this is going to be garbage collected, and that's going to be collected, and it has to definitely use the singleton object pool, but it will also need to include or use the include slash garbage collected.hpp, which we're about to write. And its name is not singleton object pool, but garbage collected, and everything else should be just fine. All right, so now we need to edit a file that is called, well, I want the HPP file that we're about to create. Let's do that first. And this is going to be in the includes GarbageCollected.hpp. There we go. It's a new one, but we'll just do our at file, and there we go, and pound if not defined, and remember I'm namespacing everything. And there we go. Okay, so do I need to include anything here? Yes, I do. I need to pound include our, what is it called? Singleton object pool.hpp. We're going to be using that. Namespace Tang. And how we're going to describe this. And recycle. There we go. And now, I think it's template. Class T, and this is going to be class GarbageCollected, and there's going to be some stuff in here. Public what? Let's just do its there. It's empty. And then under, do I want to do this under protected? No, I'll say private. And a pointer ref. There we go. Don't forget the closing semicolon, Corey. Okay, I wrote it. And this should be and we're going to do this. We're going to say that the params are, I don't know how to say variable. What I mean by that is it's going to be passed on to a variable number. I'm going to have to look that up to see how to document that in Doxygen. But it is the variables to yeah, I didn't think that would fit of the specified type. There we go. And now we need a test. So we're going to do test, not test CPP, but let's do GarbageCollected.cpp. And I want to or should these be included? I don't think that these should be included. I think I'm going to get rid of these. Yeah. Either way, I know we're going to pound include garbage collected.hpp, and what else? Pound include, I think, is it gtest/gtest? That seems right. And I'm going to say and then what are the others here? Test. There it goes. Like, I don't know why it pasted in folded, but ZO is, or at least are my shortcuts for opening the folds. You know what? This should actually compile at this point. Let's get this going. Let's see. Make watch dash test. I don't like the name of that. I'll probably change it to test dash watch. No such file or directory. Oh, and I know why. Let's go back to the make file. Is that one? Yeah, so I put this here, and I'm going to say that and Y to yank it, and now test. I need to add it. There we go. And it says no such file. Why is there no such file? Probably because I did it wrong. Before, it's gtest/gtest.h. And why does it have this? Probably because this program contains tests. You can use the following command line to control its briefs. Okay. Instead of brief. I did it twice. There. Okay. So when it running garbage collected, 0 tests from 0 suites ran because we haven't written anything. All right. So what do we want to do? First of all, I haven't thought this far ahead, so I don't have anything planned. We know that we want to, what is it? Test and can we create an object and get to it? So this is just yeah, we can do this. Sorry, I'm thinking out loud. So created object. No, not created object. So create and access. I don't know if I like that, but that's what I'm doing. So now why it keeps on indenting so far. That is weird. Yeah, I'll have to figure that out. So we've got this garbage collected. So I'm going to say a garbage collected computed expression integer. And I'm going to call it G1, maybe? I don't need to G. But I want it to feed in the value of 3. And what do I expect? I expect to be equal G, and I want to get at it, get at the value there, and say dump, which should dump a string, and that should equal a 3. That's the goal. It's not going to like any of this, by the way, because it's going to say computed expression integer was not declared well. I don't know whose fault that is. Pound include computed expression. All right, and now it doesn't know what to do with the brace and close initializer list. And that's what we're doing next. Okay. So, let's say here we are. All right, so we are at our garbage collected is the name of the class. It is templated. And we can pass in computed expression integer. That's fine. But whatever we then initialize it with, that's this part right here, we want to pass it through to the constructor. So let's do this. Nope, didn't want to do that. For this, you do ... and most people just call it args. And that is saying that there's going to be a variable number of things, and they're not all even the same type. I'm sorry. There we go. Now what do we do with this information? We say that should be right. Oh, no, it's not. That should be right. Okay. So far, expect equal dump. What's it not liking? Comma or semicolon before switch. Did I forget something? Yes, I did. There we go. Okay, now it says it doesn't know what to do with the asterisk, or not with the asterisk, with the pointer, because it's whatever. it's a non-pointer type. That is Tang colon garbage collected. Yeah, so it's saying I don't know what to do with it, but we can tell it what to do by using operator overloading. So buffer 2, and we will do this as a access the referenced object as a pointer. Sure. And so the return type of this is going to be T star, where T is our templated class up at the very beginning. Template class T. So that's that. And it's going to be operator that. I'm going to call it a const because we're not actually changing it, but we're just returning it. Turn this ref. That should work. Wait, it did. I'm always skeptical when something works so fast. It worked. All right. B4? No, B3. I'm just going to get rid of this. Control B, D. There we go. And well, this is for creating accessing. Okay, so I think I'm also going to do a star G dot dump, and I want that to work as well. And now it's going to say don't know what to do with the operator star, but we know we want it to be the actual computed expression integer, right? Oh, but that probably, well, it should work, but will it? Yes, it will. Sorry. Okay. Yeah, it should work. So let's go back to this here. We want to access the referenced object. And I guess we should have added return object, whereas this one is going to return not a ref. It's going to say it's going to be I shouldn't be saying referenced because this will return a reference to the I think I like tracked object better. So this should be tracked, and this should also be tracked, and this should be tracked. Okay. And this is now a T ampersand because we want it to not return a copy of it, but the actual one. And operator star, open close, const, and we will return Yeah, that seems right. It passes the test. Good. Good, good, good. All right, and I may have to pause this recording. My brother's calling. One moment. All right, I'm back, and yes, that was my brother calling. And so, all right. Where was I? We just we're passing our tests. That's always scary when it works. And but what we're doing is we're just creating a new one and we're not deleting it. So we wouldn't pass a memory test, right? It would say, no, something's going on. So let's go ahead and write our destructor and say, no, all right, and this is going to be tilde or tilde, whichever. Garbage collected, and right now I'm just going to say delete this arrow ref because we're not tracking the count. Now at this point it's still going to pass the test, and what I want to do is I need a counter. So count okay, and I should also do something for ref. All right, so we've got that now. Count should be initialized. Well, I'm not going to do it to here because what if it throws? Because we can't initialize. So I'm going to say this count is equal to 1. And now in the destructor, I'll say minus minus this count. And then I'll say if, you know, I could do it here. This arrow count is equal to 0. Then, oh, I'm putting this in the wrong place. It should be in the destructor. There we go. If minus minus this count is equal to 0, then there we go. Delete the reference. Now, I'm going to stop here and just point out something. This is not thread safe. And in fact, I'm going to put that right now in. Does that bother me? No, because I know how I'm going to use it. What do I mean by that? Well, I'm using this this garbage collected thing in a single thread, and all of the processing that's going to happen is going to happen in a single thread. And by the way, the threading part is part of the problem with the shared pointers, is because it's constantly having to check if it's in a threaded situation and dealing with the mutexes and everything like that. So, and that slows it down. So I am intentionally not writing. I'm intentionally writing something that is not intended to be used in multiple threads. That's the first thing. Second thing is the object pool, however, is thread safe. I use mutexes to control the access to the different parts. So why is that good? Well, it's a singleton class. That means I can have many threads. One thread can request computed expression integer, and a completely different one can request a computed expression integer. The pool will be okay thread safe wise, but this garbage collected container thing will not pass between threads. So we can use that knowledge of how we're building this to our advantage to say we're not going to have an issue by making this not thread safe. Yeah, that's what I'm trying to say. All right, so we've got that in the comment, and we've got our count, and we create the count, yes, and we delete it when it's safe to. If I save this, still passing the test. All right, what do we need to do? We need to now, we think about it. We had to write a destructor, which means the rule of 5 kicks in. We need to write the other 4 because the destructor was one of the rule of 5. What are the other 4? It's going to be a copy constructor, a move constructor, a copy assignment, and a move assignment. We have to take care of all of those. But first, let's write our test that will make sure that it's working correctly. And at this point, by the way, I'm not, I haven't even stubbed this out. So that is on another thing that I'm referencing. Nope. This is, at this point, we are 100% flying by the seat of our pants. So, okay. Is this the .txt? Okay, so we know that we can access something. We want to copy it. I think that's the first thing. So I'm arguing with myself how I want to do this test, and I think it's just going to be rule of 5, and this is going to be copy constructor. And how do we test this? We're going to then say yeah. We've got our this. Now we're going to say auto G2 is, yeah. No, that's going to be an assignment. Well, I'll just do it this way. There. Auto G2. And then okay. I'm going to call these, I'll call the other G1. G1. Okay, and this G1. Now that's going to pass. The problem is, I'm surprised it didn't give us a memory error because we haven't written the constructor yet. I want to now say the value in oh, can I get at the value that way? I haven't written an operator equal. Yeah, I can't do it that way yet. Okay, never mind. We'll do this, but I will go back to, and let's write our copy constructor. The parameter is all right, and what does this look like? Garbage collected, and it, why am I putting a space there? I shouldn't be putting a space there. I'm not doing it on any of the others. I don't know why I was doing it there. Okay. So what do we add? It's always a const because we're not going to modify it. Collected, and it probably doesn't want, because I'm wanting to put this, but anyway, garbage collected ampersand GC other. Yeah, we'll do other. All right, and now here's the problem. They're going to have different counts. And we need them to share a count. So I'm just going to go ahead and say size t must be a pointer to count. Yeah. Yeah. That's the best way to do it. A pointer to count. And so when I collect it, I'm going to say is equal to new size t with a value of 1. And now this is not just delete ref, but delete this arrow count, and now we also, am I using this? I know I need to change this up here. I'm doing it right now. There. That should compile, except I think I kind of stopped in the middle of something I did right here. So what I want to do, I'm going to say this count is equal to other count star plus plus this count, and this ref is equal to other ref. And now they're pointing at the same thing. Yeah, you can't use the, well, it's not a pointer, it's an object, so you should use the dot notation. And it's sometimes I'd look at myself and say, why did you do it that way, Corey? There we go. Yay! So this arrow count is a pointer that we are dereferencing and then incrementing. So, yeah, increasing the count, and we're sharing the reference. Now, when we're destructing, we're decreasing the count and deleting it. All right, good so far. Now let's do the move constructor. And remember, a move constructor is one in which at param the collected object to move. All right, so a move constructor, garbage collected, and it's no longer const. It's going to be a we're going to steal its stuff, basically. In order to do that, first we have to can we do this is my question. Can we call our own destructor in this way? Unused parameter other. That's fine. Where does this go? I think it's just for the moment. It's just saying this that's on line 57. Maybe uninitialized when G2 is declared. Okay, so it's doing a test, and by the way, that's a good check because it's now checking this here. Let me just finish this. So now I'm going to say I'm stealing that's fine. Now I'm going to steal. Move the members, attributes, and anyway, it's going to be this arrow ref is equal to other.ref. Other.ref is equal to is that right? And this arrow count is equal to other dot count. Is this right? I have to ask myself that a lot. What I'm doing first is I'm going to remove from the current object. Okay. And then, do I want to do it this way? Okay, so why am I doing it this way? I'm saying that I know it's saying it may be uninitialized, but I'll fix that in just a moment. My thought process is, first of all, it's no longer unused. My thought process is I'm signaling that mine, whatever I'm tracking, delete, or excuse me, remove a count from it. And that count, that's what I'm calling my own destructor. Normally you shouldn't call a destructor. I know that. But I'm doing it here. I'm calling my own destructor just to decrement my count, and if something is there that needs to be deleted now, delete it. And now I'm going to reset my reference to the other object's reference. I'm going to reset my count to the other object's count, and now I'm increasing the count. You say, but if this is a move, why? Well, because I'm basically pointing to their references, and now when they go away, when their destructor gets called, it will then they will decrease the count. So I added one, and then they remove it. So we'll be at the same count, and because at least there'll be one, it won't go into this if statement at all. So this should be correct. Now, why does it not like this? G2 count may be uninitialized. And that's on line 63. Is it possible for it to be uninitialized? I don't think so, but let's see. I've got a copy constructor and a move constructor. Let's do the others. Let's do a copy assignment. That's the word. Copy assignment. And the param is sure. And this is, now it's got to return something anytime you do an assignment, so it's going to return a garbage collected and a reference to it. Operator equals, and what am I being fed in? This is a copy, so I'm promising I won't change it. So const garbage collected ampersand other. That seems right. And this is largely going to follow the copy constructor. So, no, wait. Again, I already exist at this point, and that means I need to call my own destructor. And then copy the other items attributes. Oh, so this really is very much the same as the move constructor, because I'm not really moving. That's the thing. This ref is equal to other dot ref. This count is equal to other dot count, and plus plus asterisk this count. Oh, and I need to return something. So return this. So that's the difference. The constructors don't return anything. So that's a copy assignment, and now the move assignment. Sure. And a move assignment is also turns an ampersand operator equals, and oh, I know what I did wrong up here. Move constructor. This should be a double ampersand. Yep. Sorry, just thought about it. Now this should be garbage collected double ampersand. That's why I thought about it. Other. And what do I need to do? I need to clean up my own. So and now same thing here. And now notice it got rid of the warning because now we've got the complete rule of 5. All right, so let's look at some tests we can do to make sure that we're doing what we expect. We know that G1 and G2 were, that should be the copy constructor. I know what I'm thinking about. I should probably tell you, right? Assuming you might be curious. How can we test these things? How do I know that I'm looking at the same thing? I could equal normally. I'm going to see if this works. The test pass. Normally this wouldn't mean anything. An ampersand and an asterisk would cancel out one another, except G1 with an asterisk will return, it will resolve to the garbage collected value. And I'm asking for the memory address of the garbage collected value. G2, I'm asking again for the target, and then I'm asking for the memory address of that. So this shows us that G1 and G2 are pointing to the same object. That is important. Oh, and you know what I don't have? We haven't done the memory access yet. So how's my time on this? The memory pool. Well, it's 2 videos, so I want to use the SingletonObjectPool. So instead of the this ref, it should be autotemp is equal to singleton object pool of type T get instance dot get. So I'm saying the singleton object pool of the type of whatever this garbage collected thing is tracking, get the instance of it, and get me a memory address, and that's in temp. Now I'm going to pass that into this. A double free or corruption. Kind of expected that. All right. Now, why? because in our destructor, we don't delete the ref. We say the pool of type T get instance dot recycle this ref. That should be correct. And the question is why did I not have to say, oh, because I'm in the namespace of Tang. That's why. So let's go back down to the destructor. And if I can remove that, I will. No more error. Now, we had to be creative in order to get our tests. What I want to do is I want to know if the recycle is working. Okay? And I can do that by cleverly, I say clever, recycle. Working. There's two tests I can think of that we can do for this. Or, yeah. So now I have to think of how can I do this? I'm going to have a integer pointer, just call it P. Set it to null pointer. Now, I've got my G1. Actually, before this happens, I think I want to do... No, I can do it this way. Why is this doing it like that? I don't know. P is equal to G1. Now, that should go away. Now this, we're going to call it G2. Give it a different number because why not? And what I'm expecting is that P is going to be the same as the memory address of G2. And it worked. So what's happening, again, we've got G1. It's brought into existence. P is set to its memory location. And then it should be gone away at this point. Then we ask for a G2, and it should be recycling G1 because we know the order, right? And when we ask for the memory location of G2, what it's pointing to, it's equal to the old value that P1, that the G1 was. So we have verified that the object got recycled. Okay, now let's verify that an object is not recycled. How do we do that? Well, we're going to have a I need to have two references to it, and I need one of them to go away. Yeah. So and by the way, then is that going to work? I mean, it'll work, but what I'm thinking is the sequence of steps I was thinking in my brain, is that sufficient? I need to create two objects, make sure one gets destroyed. I know how to do it. Okay. So I've got this. I'm going to put it here. It's on the outside. All right. Now, I'm going to auto G2 from G1 have no idea why it did all that. So G1 there we go, and P is pointing at whatever 2 is now, and maybe that's not right. Well, no, I want it to not go away, so that's just to make sure it happens. So I'm going to make this a P1 and a P2. And we will say P1 is equal to memory address of G1. Okay, and now P2 will equal that one. And now G2 should go away. P2 is still its memory address. We expect P1 and P2 to be the same. Right? Now, we're going to have a P3. No idea why I did that. Evidently I can't type. And I'm going to call this G3. Give it a different number, why not? And if I say P3, this should give me say it failed. P3 is null. Oh, because I didn't set its value. So P3 is equal to ampersand star G3. Now it should still fail because, and I want it to. I want it to fail. I just wanted to verify. And that is P1's memory address is here. P3's memory address is here. It makes sense, by the way. It's 16 bytes in size, and it stores 2 pointers. That's why. Okay. 16 bytes. That's usually a line of cache on a CPU. Cache. That's what I meant to say. So that's a good size. So it's expect them to be not equal, and now that test should be passing. Good. So we made sure that it's not recycling something. P2 did get set, and we know that that works because we tested our copy stuff up here. So it knows something's getting copied. We tested that an object is getting recycled. We tested when an object is not getting recycled. And I feel like I should probably do more tests. But you're probably getting bored watching this. So, in short, right? Let's now I want to see that again. Vim. No, test. In the test, garbage collected. Yeah, it's behaving now. I think it was because I opened it directly in a buffer and it didn't like that. So maybe I should touch the file first and then open it. Let's test the include that we just created. V, G, and tell it to redo everything. Of course, it moved these, and I didn't quite want that. There. So I do my alignment of the word public against class. Don't know why. Just that's how I've seen it a lot. I also evidently it moves the template, and I don't like that. Oh, well, for that matter, this entire class. We need to move it in. There we go. Okay. Namespace Tang. We've got our template class, public, copy constructor, move constructor, copy assignment, move assignment, our destructor. We're using our singleton object pool. We've got our arrow object access. We've got our asterisk, our dereferencing access. And it passes our tests. Yay. All right. Let's see where we are. So what's our diff to our make file? That's going to be just adding the target for the test garbage collected. We added the gtest brief is equal to 1, and we're running all three. Good. Make file, git add. Well, we can just do include garbage collected and test garbage collected. All right. All of those. In fact, where are we? Almost 900 lines total. But we're to the point now where we're almost where we're. I'll just go ahead and say it. The next thing we're doing is we're going back and we're changing our usage of how we parsed a 3 and returned it. Now we're going to use our garbage collected value. And when we do that, then we can go to town and start making the rest of the language. But we had to get all these parts in. We had to have an object pool. We had to have some sort of garbage collecting thing, even if it's only reference counting and not doing some of the other more sophisticated methods. This will be fast though, and that's what I'm looking for. So let's do our documentation. Make sure that works. Make docs-pdf. Good. WSL view, and that's docs HTML index. Under our files, we should have, well, let's just go there. A singleton object pool and garbage collected. I don't have descriptions on those. Huh. I'll put those in for next time. But if we look at it, our singleton object pool, oh, we saw that last time, but now we're at the garbage collected. And which calls singleton object pool, mutex iStream, and we've got, it defines this class. All of our documentation is there, and yeah, very happy about that. That's it. Our garbage collector is done, and next thing is that we'll be incorporating it into our current virtual machine, and then we get to start writing more of the virtual machine stuff. Maybe next time we'll be able to parse a float. So anyway, all right, well, thank you, and hey, I hope you have a great day. Bye.